And now we're going to try to prove that this sequence given by an 1 over the square root of n squared plus 1 plus 1 over the square root of n squared plus 2 until the last one, which is 1 over the square root of n squared plus n. Okay, we want to prove that it has a limit. Okay, first thing that we need to notice is that an is positive because it's a sum of positive numbers. Okay, we can rewrite an in the sigma notation as the sum of 1 over the square root of n squared plus k, where k is from 1 to n. So this is the general form of the sigma notation. Okay, now we're going to use some easy steps, some basic algebra to show that this limit exists, but we're going to use the squeeze theorem basically. So what we can do is we're going to find an upper and a lower bound as sequences for this an. So our aim here is an will be between some bn and cn. Okay, and we take the limit here for this bn and for this cn, they will be the same, and after that we're going to conclude that this one has the same limit. Okay, so what we're going to use algebra. Okay, so assuming that k here is between 1 and n. Okay, so we're going to try to find an expression for the square root of n squared plus k and invert it. So now if we add n squared to both sides, we're going to have n squared plus k is less than n squared plus n and bigger than n squared plus 1. But this one here, we're going to make it easier. We're going to say it's less than n plus 1 square. Okay, to just make the algebra easier. Okay, now we can take the square root. Okay, so the square root of n squared plus k is bigger than the square root of n squared plus 1 and less than the square root of this one is just n plus 1. Now we flip everything. Okay, so the order is going to change. So n squared plus k is going to be between 1 over n plus 1 and 1 over the square root of n plus 1. For every k between 1 and n, this one will be trapped by these two. So this sum here for k equals 1, it's going to be between 1 over n plus 1 and 1 over the square root of n squared plus 1. Okay, so when we do the addition for every k going between from 1 to n, so we're going to have this sum here. Okay, so it's going to be here, it's going to be 1 over 1 plus n plus 1 over 1 plus n plus 1 over n plus 1 is going to be between here. So, but before that, I need to explain one more step. So here, 1 over n plus 1 square root is going to be between n and 1 over n plus 1 and 1 over square root of n plus 1. The same thing for 1 over n squared plus 2 is going to be between 1 over square root of n plus 1 and 1 over n plus 1. All these terms here, each of these terms will be between these two. Okay, so when we add them, so we're going to have, how many terms here? We're going to have n of this one. So we're going to have n over n plus 1, okay, less than the sum of the 1 over square root of n squared plus k between 1 and n, and less than how many terms here? So here when we add these ones, this term, it's going to be how many? It's going to be n of them. Okay, this one will repeat n time. So it's going to n over n squared plus 1. Okay, so this is my sequence. So this is in, and it's trapped between these two. And this one, I'm going to write it this way. So I'm going to write n squared over n squared plus 1. Okay, now I have my two sequences, this one and this one. So what's the limit of this one as n goes to infinity? It's 1. This is my limit. And what's the limit here as n goes to infinity? It's 1. Therefore, my limit is trapped between 1 from top and bottom. That's it. From both sides. So my limit is 1. Okay. I did skip some steps here, but they're clear. So each term here will be between these two. Each term here will be between these two. And how many? One of them, n. So when I add them, I'm gonna have n of these. So it's gonna be n over this one and n over this one. And when I take the limit here and here, I'll get 1 from both sides. And therefore I can conclude that my limit is 1. Okay? So I think it's very clear here. The most important thing is here. Okay, is try to find a upper bound and a lower bound as sequences for my sequence. Okay, and I think that's it. Thank you very much.